Hello everyone, my name is Abhimanyu and today we are going to understand cubic polynomial function. Any polynomial function which is in the form of f of x equals ax cube plus bx square plus cx plus d. Since this polynomial function has a degree 3 which is the highest degree of the polynomial, so it is known as cubic polynomial function. Now since it has a end behavior, so we have to understand what is the end behavior of this polynomial function. So end behavior of a polynomial function would be determined by two things. One is on the basis of degree and other with the term that is leading coefficient. So since it has a degree odd and leading coefficient is a. So since the leading coefficient of this polynomial function is a. Now if degree is of a polynomial function is 3 which is odd. So if a is our greater than 0, that is if our leading coefficient is positive, and other cases if our leading coefficient is negative, that is a less than 0. So if the leading coefficient is positive and degree is odd, so the polynomial function would behave will start as x tends to negative infinity, y also tends to negative infinity, so it would in the third quadrant, and as x tends to positive infinity, y also tends to positive infinity, so it would start from basically it would go from the third quadrant to the first quadrant, or we can say that it has an end behavior of the third quadrant and the first quadrant. Now after that we also have to understand that what is the end behavior if a is less than 0. Since a is less than 0 means a is negative, leading coefficient is negative and degree is odd, so as x tends to negative infinity, y would tends to positive infinity, and as x tends to positive infinity, y tends to the negative infinity, so it would be in the first, no, it would be the second and the fourth quadrant. Now so we have seen the end behavior on the basis of degree and the leading coefficients. Okay, let's move. Now after this we will try to understand what is the zero of a polynomial, factor of a polynomial, solution of a polynomial or roots, and x-intercept of the polynomial. So what are the difference between these terms we are going to understand here now. So as we can say that if k is a real number, and if we can say that if k is a real number, then 0 of the polynomial means if we substitute in place of x the input as k, we'll get as output as 0, so it is known as 0 of the polynomial. Now what do you mean by factor? If k is the 0, then x equals to k is one of the 0, so x minus k is the factor of the polynomial, is the factor of this polynomial equation. Now of the equation, what of which polynomial equation? X minus k is the factor, f of x equals 0. Now after that, if what is the meaning of the solution and the roots? So the solution and the roots of the cubic polynomials are basically, we can say that if k is a root of the polynomial, if k is a root of the polynomial equation, we can say a polynomial equation would be f of x equals 0. Now if k is the root, then we can say that such that k, if we substitute k in the place of x, we will get 0. So that is the solution or the root of the polynomial equation. Now we can also tell us that if there can be since it is a polynomial equation of degree 3, so it has 3 roots. Now 3 roots can be of 2 types. One root can be either there is a 3 real roots, or there is a possibility that 1 real roots and 2 imaginary roots. Now you will ask me why 2 imaginary roots. So there is a theorem that we have to understand that is known as complex conjugate theorem. So according to which we will say that the roots or imaginary roots always exist in pairs. Okay, so it has since it is a degree 3, so it has either 3 real roots or 1 real and 2 imaginary roots. Now what is the meaning of the x-intercepts? If we can say that k is a root of the polynomial, and if k is a real number and k is a root of the polynomial, then the k is also known as the x-intercept, such that the f would pass through k comma 0 on the point k comma 0. That is the meaning of the x-intercept. We have understand that. Now next, let us take an example to make it concept clear. If we have a polynomial function f of x equals x cube minus 7x square plus 8x plus 16. So if there is a theorem known as rational roots theorem, according to which we will describe the possible rational roots of this cubic polynomial, and when we will solve it and when we will factor it, so we will get as x plus 1 whole square, that is -1 is one of the roots and 4 is one of the roots. So x plus 1 no, the multiplicity of 1 means x plus 1 is just 1. So and x minus 4 has, that is x equals to 4, the roots, it has a multiplicity of 2, that we call it as x plus 1 times x minus 4 whole square. After that we will also see that what type of graph does this polynomial function would be. So since the x-intercept is x equals -1 and x equals 4, so and 4 has a multiplicity of 2, so 4 will touch and touch the x-axis. Now as we can see it here, that x since it has a leading coefficients positive, so x equals to, for example, -1 is here and x equals to 4 is here, so it will just pass the x-axis. So it would just pass the x-axis, and as soon as it would pass the x-axis and it would touch the x-axis at x equals to 4, it would touch the x-axis at x equals to 4 and it would cross the x-axis at x equals to -1. So this type of graph would be there. Now if f of x is a cubic perfect cube, then since as we know that this is x minus 1 whole cube, so as it has x equals to 1 is only the one distinct real roots, so it would, as we can say that now since its leading coefficient is positive, and so it would just pass through the it would touch and just pass through this point, and this is the end behavior of the polynomial function. So this is the graph for a cubic polynomial functions, and that is the horizontal shift of +1 to the right. Thank you.